Hi, welcome back. So the objective is we are going to learn about Hdfs and MapReduce in detail. In this session, we are going to understand what is Hdfs. I mean the concrete distributed file system that is provided. On top of it, what a Hadoop is working, and we will have a solid understanding about the framework that's MapReduce. What are the fundamental components that make up the MapReduce? So while introducing this, Hadoop started few years back and it has gone to iterations. So the first iteration we call them as the old MapReduce 1 and the latest one we call as the MR2. So I will be using Hadoop 1 or Hadoop 2 or MR1 or MR2 interchangeably. So MR1 or Hadoop 1 depends the old distribution of Hadoop. The MR2 is the latest distribution of Hadoop. Okay, we will see what is the what got different within these two versions. The conceptual understanding of the distributed file system didn't change. The programming abstraction provided by MapReduce didn't change. The only thing that got changed between this MR1 and MR2 is that how the infrastructure is set up. So even if you don't understand the difference between MR1 and MR2, the way you write MapReduce programs are not going to change. The way you interact with the Hdfs file system is not going to change. But having an understanding helps you to understand how the system is progressing from one version to another version. Okay, so let's get started. So a recap of MapReduce. This a programming model based on simple concepts, that is you iterate over input, computation of key value from each piece of input, grouping of intermediate value by key, iteration over the resulting group, reduction of each groups. Okay, that's the conceptual understanding behind the MapReduce phase. Distributed file system. So we understood that MapReduce needs a distributed file system that can manage large files across multiple machines. MapReduce needs a distributed file system that can replicate data so machine failures don't make data unavailable. MapReduce would leverage meta information provided by distributed file system to execute code on nodes where partition of data is located. Okay. So HDFS. So HDFS is actually the distributed file system that is built for the on the conceptual understanding of distributed file system that we want for Hadoop. Okay, so Hadoop distributed file system. So as we figured out, this is derived out of distributed file systems from Google. So this HDFS is highly fault tolerant and designed to be deployed on low cost hardware. Okay, that's like when we say low cost hardware, it is commodity hardwares. Okay, provides high throughput across access to application data and is suitable for application that has a large data set. Okay, so that's the fundamental objectives of it. Okay, you have to have a high throughput access to application data. Okay, then any application that needs a large amount of data, or if you have to build an application that has to work on a large amount of data, the high throughput is needed. And we also have seen that how HDFS is giving you a high throughput because it splits the data and then keeps it in multiple machines, and each machine is working on a smaller piece of the data. Okay, so that is how you get a high throughput to the data. Okay, as we saw, it can be built on commodity hardware. So HDFS design principles. Okay, when HDFS was designed, people thought from one fundamental change in their thought process, because they're building on commodity hardware. They thought failure is a norm, it's not an exception, which means that when you design a system, they know that few parts of the system will fail at random almost on a daily basis. So how do I build a system that even if a partial failures in the hardware setup happens, things can work? When I say partial failures, if one of the machines fail in the cluster as such as a whole can function, because whatever data or computation that can happen on that particular node is already available in a replicated fashion. So unless the entire setup or considerable amount of machines in the cluster fails, the cluster itself will be up. So a HDFS instance may consist of thousands of server machines, each storing parts of the file system's data. At any point of time, there is a high probability that few components are non-functioning due to high probability of system failures. Detection of faults and quickly recovering from them in an automated manner is the core architecture goal of HDFS. This point is what you need to understand very well. Well, that differentiate between other systems and Hadoop. In Hadoop, it's not only about system can function with partial failure, but it is able to detect some machines are failed in the node, and those machines are automatically marked as failed nodes and they are kept outside of the cluster, and the system manages internally to make sure that uh, the cluster as a whole is aware of which machines are functioning right away and which machines are not, and it knows where the data is available. Say for example, let me give an example. If you have a piece of data, a file, let's say that the file is 10 MB in size for the sake of understanding, and you have split this file into 10 blocks, and each block is kept in machines. So ideally you need 10 machines where these individual blocks are kept. So as we also figured out, HDFS or Hadoop is designed for failure and replication failure. So they avoid failure by replicating. So what the strategy that took was, so instead of keeping this file in 10 blocks in individual machines, let us keep this 10 blocks in 10 different machines, and each of these blocks should be replicated. So 3 times. So overall, each the file is the 10 blocks, each block is replicated 3 and they are kept in different machines. So as a count, if you see, there are 30 blocks in 30 different machines. Okay, and the cluster knows about this. Cluster knows where to look for these blocks, in what order they can look. Assume that one of the machine is failed. Immediately the HDFS file system, HDFS will come to know the failed nodes, because the failed nodes will not be able to give you a heartbeat. Each node sends a heartbeat to the system to make sure that they are functioning in the system. If the Hadoop doesn't get the heartbeat from any of the slave machines, it knows that the slave machines are no more in the cluster. The immediately whatever the corrective measures it will take is, it will make sure the failure is communicated to other machines so that this machine is first removed from the cluster. So the Hadoop is not scheduling any job to be run on this machine, or Hadoop is not using this machine to write some files. Second thing it will do is that any data that is available in that machine, it needs to route it to other machines, and any job that needs to be done on that machine will be routed to other different machines where the data is available. So this is how detection of faults and quickly recovering from them in an automated manner helps HDFS to be one of the most popular distributed computing framework. When I say HDFS, I'm talking about Hadoop, and the HDFS file system is much more reliable for doing MapReduce kind of a computation. So HDFS architecture. So HDFS, as I say that in the there are, it also, when I say Hadoop went to iteration, it is also about the HDFS. So the HDFS is now previously available as only one architecture. Currently, with the latest version of Hadoop, HDFS is available in two architectures. One is a highly available mode, and other one is in a federated mode. So we'll have a brief understanding about what is high HA mode and then federated mode. So HDFS in the HA mode, okay, we will talk about the highly availability mode. So HDFS cluster consists of two name nodes in a HA available in a highly available mode. So that's like one is called an active and then it's a standby. So the active one manages the client operation in the cluster, manages file system namespaces, and regulate access to files by client. So standby manages the metadata information similar to secondary name node as in the old version of HDFS. Okay, many data nodes, typically one data node for a physical node. So that is how they are split this thing. Okay, it's highly unlikely that there are two data nodes in a single physical machine unless you have virtualization on that machine. Okay, so ultimately when we say a single machine, we are not talking whether it is a VM or whether it is a real machine. Let's talk about a single machine. In a single machine there will be one data node. So data node manages storage attached to this node in which they run. HDFS exposes file system namespace and allow user data to be stored in as files. Okay. File is split into one or more blocks and a set of such blocks are stored in each data node. The name node executes file system namespace operation like opening, closing and renaming files and directories. And name node determines the mapping of blocks to data nodes. Data node serves read, write, perform block operation, delete and replication upon request from name nodes. So here you need to understand the responsibility is clearly differentiated. The actual reading and writing of the file systems is done by the data node. Where the file has to be written on which are the data node that in which the file has to be written is all determined by your name node. Okay, the name node is the arbitrator and the repository of all HDFS metadata. The system is designed in such a way that the user data never flows through the name node. So name node only manages the meta information. The actual data flow and the actual read-write operation is undertaken by the data node. So HDFS uses namespaces to manage directory files and block level information. As you know, in such system there is a limitation of single node failure, limiting on the number of namespaces. So new generation Hadoop allows to have multiple namespaces by having multiple name nodes. That is the federated name nodes. So in the previous thing that what you saw is a high availability, and there is another architecture that is called the federated mode architecture. So since we know that if you have things using namespace, two things will happen. One is a namespace collision will happen, and a single namespace will reduce how big your cluster can go. So to have a really very large cluster, you have to go with a federated approach. So the HDFS in a federated mode, you need to have it. So this is the overall architecture of the HDFS. So you see, we'll talk about the yarn shortly, but then if you look into it, if you see client uses the HDFS, the master for meta operations, but then it also has directly attached to the slave nodes, that is the data node, for doing any of the read write operations. Okay, and if you see on the right hand side there is a yarn master node. So yarn master manages your slave nodes. Okay, if you clearly see, if anybody who is coming from MapReduce 1 who has worked on MapReduce, they would have seen that the the slave nodes were used to be managed by the Hadoop system itself. Now management of the cluster is given to a different process called yarn. We'll briefly look into that one. So in each slave node there are different daemons that is running. One is a node manager and one is a data node. And you can see some of the slave nodes run something called as an application master. And you're seeing something as containers over there. We will talk about it detail. So the HDFS daemons. HDFS cluster has two daemons, name node and data node. Client accesses the file system by communicating with the name nodes and data node. End user application use client library similar to POSIX file systems. End user application means the application that is using the Hadoop system. So these are some of the simple commands that you can work. I can actually show you at the end of this course about how to do these things on a real Hadoop. Okay, so all you're seeing is that copying a file from a local machine into HDFS file system. You run Hadoop and then you say it is a file system command that you're interested to do work, and the copy from file is the command that you're giving. Input slash data.txt is your actual text file, and slash user slash data.txt is that where you're going to copy this file. You're copying under slash users folder and naming that file as a data.txt. So you are reading a file from your folder called input slash data input, and the file is data.txt, copying it into HDFS file system called slash user, and then the file name is data.txt. So other commands are also follow the same thing, copying a copying HDFS file system to a remote file system. Instead of copy from local, the command we are using is copy to local. So we can actually experiment with all these file system commands later. So understanding MapReduce. So we have to think about what are some of the problems that people are using for MapReduce. So as I told you in the beginning, MapReduce started with Google. When Google wanted to create this search engine, they wanted to do a whole lot of computation on all the data. So one of the fundamental tasks at them they wanted to do is build an inverted index. So an inverted index is, we all know index that is there in the back of the book. So inverted index is one master index which has information about all words and its occurrence in all the files that are available. So let's take an example, repository of documents from web call as an input and word based index for the web search as output, where the intermediate key value of this key value pair of the form word comma URL. Okay, so the thing is that for each word you need to know which are all the documents that are available on which this word is available. Say for example, if I give a word called dictionary, we should have in what all documents this word dictionary is available. The actual real index that we have is, if you give a word called dictionary, if you could turn the end of the book and see the index, it will show which are all pages this index is available. So what we are going to do here is, I mean, what Google did was, for doing searching, the fundamental thing it needed is, at least given a word, it needs to have in which all documents this word is available. So now think about how such kind of a computation can be done. This is where Google introduced MapReduce based computation to do it, and it also introduced Hdfs to store huge amount of a file, and it introduced MapReduce to do this kind of a computation over large commodity hardware. So Hadoop architecture. So MR2 MapReduce architecture is very different from MapReduce 1 architecture. So user of MR1 understand this difference. First time Hadoop user could also benefit from understanding the evolution of Hadoop. So the MR1 or what we call a MapReduce 1 is composed of 5 daemon processes. So there are basically two different systems. One is a master, one is a slaves. So there will be a single master and multiple slaves. On the master, what all things runs? So a name node, a secondary name node, and a job tracker runs on your master. On the slave node, what happens is task tracker and data node. Okay, these are all the daemons that runs on the slave nodes. So MR2 splits the system into two. One is a resource management is differentiated, I mean is separated out, and data processing is separated out. So when I say data processing, MapReduce is just one way of doing distributed computing, as I told long time back. Okay, over a period of time, there are a whole lot of other data processing system evolved, like Strom, Tez, Spark, a whole lot of things came into picture. Okay, so so the cluster, so the way that they designed is that, okay, the resource management and the cluster management should be separated out, so that any kind of distributed computing can be done over the cluster. So they removed the cluster management from the computational aspects of it. So introduce yarn. So yarn is yet another resource negotiator to manage the cluster. Okay, the difference between MR1 and MR2 is there. On the left hand side is the MR1 architecture, and the right hand side is the MR2 architecture. So in the MR1 there are only two things. One is the Hdfs file system and another is the MapReduce and cluster management. So the MapReduce had name node, the master node as well as the slave nodes. The master node is responsible both for the data processing as well as your cluster management, all clubbed together. And in the MR2 architecture, between Hdfs and your computational thing, you have yarn. That's a cluster resource management. So on top of yarn, you can actually have MapReduce, Strom, Spark, anything that you want to do as your distributed computing system. So we'll have a little bit more understanding on what is yarn. So yarn is, as I said, it is yet another resource negotiator, which fundamentally tells that, hey, I have this big cluster and let somebody manage this cluster in a container or in a compartment, in a container based approach, which means anyone can ask this yarn to get few resources to do their computation. So they can actually negotiate for resource with the yarn. Say for example, MapReduce needs to run The MapReduce can ask the yarn, hey, I need set of resources to do this computation. How much of resources are you going to allocate to me? So the yarn will allocate few of the nodes and then give it to the system. At the same time, yarn can simultaneously run few set of machines for a whole lot of different computational needs. Okay, so that's where yarn comes into picture. So to cluster management and work with non-MapReduce data processing system also. Yarn itself is composed of two daemons. One is a resource manager and one is a node manager. So resource manager runs on master, node manager runs on all the worker nodes. So here we call this as simply as a worker nodes or all the slave machines. So we'll be interchangingly using slave or worker machines, which means those machines that will do the physical actual job. Okay, and there is a master machine which manages your metadata information and a whole lot of other details. Okay, as I said, they are composed of two daemons. Resource manager runs on master nodes, does resource scheduling, handles resource allocation between applications. When I say application, MapReduce as a whole is a concept. I am running one MapReduce program to create an inverted index. This is one application. There can be another MapReduce job running simultaneously to do solve some kind of a linear regression problem. That is another MapReduce application. So we need to start understanding the conceptual difference. One is a cluster as a whole, one is MapReduce as a concept and an application that you are building which leverages the MapReduce and the cluster. So this application is your inverted index, the application is your machine learning algorithm, the application is to create to solve some of the computational needs. The application is your solving nearest neighbor problem. So whole lot of things is an application. So simultaneously in a cluster there can be multiple applications running, each one doing different kind of a MapReduce jobs. Okay. Node manager runs on the worker nodes, communicates with the resource manager. So resource management, MR1 versus MR2. So in the MR1, fundamental computation is task. A task can be a map or reduced task. Each task runs on a data node. Job tracker does resource management cluster and also manages each task. It's a task tracker. Okay. So in the MR1, the concepts are much more simpler. They say there is a master and there are lots of slave machines. In each slave machines, I run what are the different tasks that you run. If you go back here and then say in the slave machines, I run the task tracker and data node. In the master, there is a job tracker. So when I say job tracker, because the cluster can run more than one jobs at a time. When I say job, they are applications. So for each application, what are all the different, how you split those jobs, where are each jobs running? And on individual slave machine, this task tracker is figuring out the different tasks that is running out there. Okay. So in the MR1, fundamental computation is a task. A task can be a map task or reduced task. Each task runs on a data node. Job tracker does resource management in cluster and also manage each task. In MR2, no job tracker and task tracker. Instead, it has resource manager and node manager. So these are the two high-level things to handle the resource management. Okay, runs on master node. The resource manager runs on master node, receives MR job from the client, schedule the MR job on the cluster, allocation of resources on the slave nodes, monitoring running jobs on the cluster, communicate with node manager on slave nodes and tracks resource utilization, using application manager for managing MR jobs and scheduler for managing resource management. Okay, so that's how the resource manager work for the MR2 architecture. Okay, so as we say MR2, instead of job tracker, task tracker and all, it has resource manager and node manager. Recap, resource manager runs on master node, receives MR jobs from the client, schedule those MR jobs on the cluster, allocates resources on the slave nodes, monitoring running jobs on the cluster, communicates with the node manager on slave nodes and tracks the resource utilization, using application manager for managing MR jobs, and scheduler for managing resources. Okay, we'll talk about what is an application manager that we have mentioned over here. So let's talk. Node manager runs on slave machines, coordinate with the resource manager for scheduling tasks and resources, uses application master and container for MR task scheduling and executing on slave nodes. So that's the application manager. Okay, so inside one of the slave nodes there is an application manager which will be used for MR task executing on those slave nodes. Okay, so if you go back, okay, I think I'll show this architecture here. Now this architecture will help. So if you look into this one, you can see that in the slave nodes you have application master which manages all the other containers over there. Okay, so life cycle. So resource manager is the master, knows about all the slaves in this cluster. So the resource manager manages everything. So to recap, what we covered in this session is that we understood what is HDFS, and we understood how what are the fundamental building blocks for this MapReduce. One is the HDFS and then the MapReduce. What is the difference between the MR1 and MR2 architecture, and we also had an understanding of the overall different daemons that is responsible for understanding this for managing this Hadoop 2 MR2. We also had an understanding of what is yarn, why yarn came into picture, and what is the difference, what are the jobs that yarn is doing in this overall things. Okay, that puts an end to this session.